Welcome to text mining video. My name is Eun-Seok Chang and I'm a doctoral student at Carolina Health Informatics program at UNC at Chapel Hill. Today, I will talk about exploratory analysis of text data. In this video, you will learn how to perform exploratory text data analysis. Exploratory data analysis in general is an approach to analyzing data sets to summarize their main characteristics, and it is often presented with visual methods. The metrics often used for exploratory analysis include mean, median, quartiles, maximum, and minimum values. In text analysis, word frequency is the most important metric for exploratory data analysis. A statistical model can be used or not, but primarily, exploratory data analysis is for seeing what the data can tell us beyond the formal modeling or hypothesis testing task. In this video, we will talk about distribution of target class and word frequencies in uni by n trigrams. Before we go on, let me introduce the dataset we will use throughout the module. The dataset we will use is a data used on research on automated classification of document citations for systematic review of 15 drug classes. The original dataset contained 18,733 articles, but to ease our computational capacity, I reduced it to 10,000 instances, to include 9 drug classes only. By the way, what is systematic review? Systematic review refers to a literature review that is designed to locate, appraise, and synthesize the best available evidence relating to a specific research question to provide informative and evidence-based answers. The original dataset is a gold standard data file of drug review topics, EndNote ID, PubMed ID, abstract triage status, and article triage status. Please go to Jupyter Notebook and run the codes there to get the final dataset we will use. After pre-processing of our data, it looks like this. There are topic, article IDs for PubMed, which is called PMID, a decision column where E denotes excluded and I denotes included for systematic review of each drug class topic. Raw text for abstract and pre-processed abstract text column. As you can see here, a majority of articles were excluded or irrelevant for the systematic review of AC inhibitors. Well, we don't have any idea about the inclusion criteria the authors of the systematic review established, but this is the decision the researchers had made. This graph shows the overall distribution of target class, that is, the number of excluded and included articles in the entire dataset. In this graph, included articles were marked 1, and excluded articles were marked 0. As you can see, only about 15% of articles in the entire dataset are relevant to corresponding topics. We can say the dataset is imbalanced. That is, there are much more zeros than ones in the dataset. In simple terms, an imbalanced dataset is one in which the target variable has more observations in one specific class than the others. Let's suppose that we have a dataset used to detect a fraudulent transaction. If we have a binary target variable that is 2 classes, that's 1 when the transaction is fraudulent and 0 when it isn't. It's normal for less than 1% of the observations to belong to class 1 or fraud than to class 0 or not fraud. In this case, we have a highly unbalanced dataset. Imbalanced classes are a common problem in text and data mining where there are disproportionate ratio of observations in each class. Class imbalance can be found in many different areas, including medical diagnosis and spam filtering. Next, let's talk about word frequency. Some words may appear more frequently than others in a document. The word "hurt" must appear more frequently in the Journal of American Heart Association than in Time magazine. The word glucose must appear more frequently in the journal Diabetes Care than the HGTV magazine. So the word frequency provides us important clues regarding the topic of the document. And there should be difference in the words used in the included and excluded articles in a systematic review. For example, suppose we review the mortality rate from stage 3 lung cancer. It is likely that the articles that contain the word mortality will be included for the review, while those do not include the word mortality are likely to be excluded from the review. There are different ways to count the frequencies of each word or token. In text mining, words or tokens can be represented as n-grams, which are a contiguous sequence of n items from a given text. An n-gram of size 1 is referred to as a unigram. Size 2 is a bigram. Size 3 is triogram. Consider the sentence, "The patient refuses hormonal therapy." In unigram, the features of the text can be represented as the patient refuses hormonal and therapy, resulting in 5 unique features. In bigram, the features are represented as the patient refuses hormonal, and hormonal therapy, yielding 4 unique features. And in trigram, it becomes the patient refuses hormonal, and refuses hormonal therapy. And here we have 3 unique features. Compound words are frequently used in the field of biomedicine, so bigrams and trigrams can provide important information of the text we analyze, such as in diabetes mellitus, acute kidney injury, or chronic heart failure, and many more. To conclude, there are many cases where we use imbalanced dataset, and word frequency can be counted as uni, bi, and trigrams. All right, let's do an exercise. Using the function and dataset provided in Jupyter Notebook, compare the word frequency in bigram between the included and excluded articles for the systematic review of ADHD. Can you notice any difference in word frequency between them? Now, go ahead, try the exercise on Jupyter Notebook.